Hello everyone, welcome to my YouTube channel. Today we are going to study about motion in a straight line. So before we study what is motion in a straight line, what is motion and how physics deals with motion, don't forget to subscribe this channel and press the bell icon so that you get the notification whenever I upload my videos. See, physics deals with vast subject. Its scope range from atomic level to nuclear level, from quantum mechanics to electrodynamics, magnetism. There is a very much vast scope of syllabus for physics. That's why physics has been divided into different branches. For example, electrodynamics, quantum mechanics, nuclear physics, atomic physics. So this is how physics has been divided. Today we are going to study about mechanics. Mechanics deals with the study of motion and rest of object. Whether the object is in motion, whether the object is in rest, all these problems related to physics are studied by the branch of mechanics. So come, let us start and understand this stuff. So mechanics can be further divided into these three branches. So sub-branch of mechanics is statics, kinematics and dynamics. See, statics deals with the study of objects which are at rest or in equilibrium even under the action of force. I am going to give you an example of this. So one perfect example of statics is that suppose I am holding this marker. Now I am applying pressure or force from both of my fingers, but still I can see this marker remains in its state at this equilibrium position. So as the marker remains in equilibrium position even under the action of force from these two fingers, this thumb and my middle finger. So to study this kind of problem in physics, the branch that studies this kind of object is statics. That is object at rest or in equilibrium even under the action of force. Next comes kinematics. Motion of object without studying the cause of motion. So this branch studies with the motion of object without trying to study the cause of motion. What is this? Suppose a question is given to you, a body is moving in uniform speed, suddenly accelerates. Now within this you don't have any idea how the body started moving, from rest. So you don't have any information for this thing. So to study these kind of problems in physics, to study these kind of problem related to physics, we deals with the branch that is kinematics. Next comes dynamics. Dynamics is the study of motion as well as the cause of motion. What is the cause for the motion as well as the study of motion? This is dynamics. So dynamics is clear to everyone, that study of the motion as well as the cause of motion. That what is the cause that is driving the object in motion as well as the cause. So these three are the sub-branch of mechanics, and we are going to study these sub-branches very precisely in this class. Next we are going to study what is rest and what is motion. Rest, I mean when a body is in a state of rest. What is the rest and what is motion? See, rest can be said like this. So rest is, what is rest? See, here I have written an object is said to be in state of rest if its position does not change with respect to a point of reference. Now this point of reference is very important. I am giving you an example. Suppose two of your friends are sitting inside a car. Now as two of you are sitting inside a car without moving and the car is moving to a certain direction. Now according to you, your friend is in a state of rest from your perspective. Now this perspective is very important. From your point of reference, you are going to say that the person is in a state of rest, because with respect to you, your friend is not moving. With respect to you, your friend is not moving. He is in a state of rest. So what is rest? An object is said to be in a rest only if its position does not change with reference to a point or reference to an object, whatever it is. So a point of reference is very much crucial to understand whether a body is in a state of rest or in a state of motion. I think this is clear to everyone. Next we are going to study about motion. How can I say that the body is in a state of motion? So for the most definition of motion, I can say a body state of motion if its position changes with time with reference to a point. So what is motion? So motion, a body is in a state of motion if its position changes with time. That is, with time its position changes with reference to an point, with reference to a point or object. Now when you and your friend are moving in a car and a person is standing outside the car and he is waving you a bye or he is trying to say you something, from the point of reference, from the perspective of the person standing outside the car, he is going to say that both of you are in a state of motion because he is watching you moving in a car. From his preference, he is true, and from your preference, your friend is in a state of rest. So point of reference is very important. So perspective, try to understand the perspective, from which perspective which person is trying to say what. Now perspective is very important. If you don't understand the perspective, you are not going to understand this chapter. So perspective is very important, and you are going to see this perspective thing in a topic called relative motion. And relative motion is very important. Now let me tell you one thing. In our universe, nobody means no one, as well as no body or no object is in a state of absolute state or absolute motion. Everything is a relative concept. Relative concept means, suppose you are moving because you are in a earth. So from point of reference of sun or any other planet, you are moving. You are also not in a state, but you feel that you are in a state because from your point of reference you are standing just quietly, but you are also in a motion because you are because you are on the earth. Now if an alien, if a person is standing on a sun, I know that is not possible, but see, try to understand, if an alien from different galaxy tries to locate you, he is also going to see you in a state of motion. Why? Because the galaxy is also moving. This whole universe is in a constant state of motion. Whatever the motion be, it is in a state of constant motion. So whether a body is in a state of rest or in a state of motion, that is a relative concept, not an absolute one. So this is clear to everyone. So next we are going to study about point object. So what is point object? Okay, so now the concept of point object. See, if the position of the object changes by a distance much greater than its own size in a given interval of time, then the motion of the object is regarded as point object. Suppose if a tiny object, just think of this, if a tiny object moves through a larger distance within a given interval of time, then we are going to consider it as a point object, motion of point object. Okay, so we are going to study everything about point object in this chapter. So try to understand what this point object is trying to say. So now we are going to study about one-dimensional motion, two-dimensional motion and three-dimensional motion. So what is one-dimensional, two-dimensional, three-dimensional? See, in one-dimensional motion we can say only one variable changes. Now what does this mean, only one variable changes? See, if I give you an example of one-dimensional motion, this will be very easy for you. Suppose consider a boy, this is a wall, this is a brick wall. Consider a boy standing over the wall. Now, if this boy tries to move over the wall, how can it move? It can move in only one dimension. That is, it can move either in forward direction or in backward direction. That means, if you consider his this motion within x-axis, that is only x-axis can move. That he can only move either forward or backward. That is, his movement is stipulated to only one dimension. Think of a train moving on a railway track. It can move either forward or backward. A train when you are seeing a train is moving in forward direction or backward direction, that is the only movement it can have. So that is an example of one-dimensional motion. So it's only one variable is changing. Which variable is changing? Only one variable. And that one is, if you consider it is moving in x direction, then only x direction is changing. No y, no z direction. Okay. Now x, y, z are the Cartesian coordinate system that you all know. We can understand this as like this. If this is considered an x direction, this has to be y direction, and this has to be z direction. So I hope this kind of dimension system is clear to this kind of Cartesian coordinate system is clear to everyone. So see this. Are you understanding this? These three perpendicular axes. This is y direction. This is z direction. This is x direction. This is y direction, and this is z direction. I hope this is clear to everyone. I hope this is clear. Okay. So now we are going to understand two-dimensional motion. Now in two-dimensional motion, two variables can change. In two-dimensional motion, two variables can change. Now example of this two-dimensional motion. Two-dimensional motion. So think of a two-dimensional area. See, this board is an example of two-dimensional area. Now if you question me how, I can say this has x-axis and this has y-axis. Now if I move from this point to this point, which variables are changing? My x coordinate is also changing as well as y coordinate is changing. So if I try to move from this point to this point, I am moving from here to here. That means I have to change two coordinates. That is, along this side there has to be change in x. This I am considering as x direction, and here along this is considering as y direction. So I am having a change of both x and y coordinate. So I have to say two variables is changing. Two variables can change in two-dimensional motion. So this is an example of two-dimensional motion. If any person moving in an area is also an example of two-dimensional motion. Suppose I am giving another example. Think of a footballer. He is running around the field. He is running in the field. So if his position is changing each and every minute, that is true. But his position is changing on two variables, x as well as y. Now if he jumps, that is a different question. If he jumps, then there is a question of three-dimensional motion. I will talk about it just now. Here only I will talk about it. So two-dimensional motion means only two variables can change. Now to understand three-dimensional motion, you can guess it right. Three variables can change. Now three variables change. Example of these three variables. Think of a mosquito. It can move along x direction. Now think like this. Think of this coordinate system. Think of this coordinate system. It can move, a mosquito can move here, right? Now it can move in x-axis, it can move in y-axis, as well as it can move in z-axis. So this is a three-dimensional motion. Now if a mosquito move from this position, from suppose this position to this position, if a mosquito move from this position to this position, then what I can say, its three coordinates are changing. That is x, y and z. So it can move along x, it can move along y, z, it can move along y also. So this is an example of three-dimensional motion. So in three-dimensional motion, these three variables can change. So this is clear. Now if you have any problem regarding this, please feel free to write me in the comment section, or you can also add me in Instagram. You can also text me there. I'll definitely going to reply you everyone. Okay. Next I'm going to talk about distance and displacement. What is distance and what is displacement? Yes, for you I am going to write over here what is the exact difference between displacement and distance. But before that, let me tell you something. Suppose, just think of these two friends. Here, this is friend 1. This is all I can say. This is Nick, and here we have this is Nick, and here I can say here lives Reshmi. So Reshmi and Nick are very good friends. Reshmi and Nick are very good friends. So if Nick wants to go to Reshmi's house, so he has to go in a road, right? Now this is how the road looks like. This is how the road looks like. So if I say Nick is moving from his house to meet his friend Reshmi, then he has to move a certain distance. So what is the distance? So Nick have to move like this, along this, again this, in this way he has to move. So this is his way, this is the direction he is moving in order to move Reshmi's house. Now see, while moving from his house to his friend's house, Reshmi's house, he has to make certain change in direction while moving, right? Now here, the next few days, after a few days, he discovered that there is another route that is like this, that there is another route that is like this. Now this is a bit short, so next day he is going to choose this route. Next day he is going to choose this route while moving from his house to his friend's house, Reshmi's house. So why he is going to choose this route? Now why he is going to choose this route? Because this is the shorter one. This is very easy. When here also, here while moving from his house to meet Reshmi, he has to change different direction while moving. So this is distance. This is distance. So distance has no specific direction. Distance has no specific direction. But what is displacement? Now if you wish to see Reshmi, he is going to go up to his staircase. He has to climb this staircase to go up to his terrace, and he calls Reshmi so that she also get into her terrace, and now they are going to look at each other. So how they are going to look? Now while looking from Nick's house to Reshmi's house, there has to be a unique distance. Unique distance means that will be the shortest one, right? That will be the shortest one. Now Nick can't look like this as he is moving, right? So this is the shortest distance. The shortest distance is the displacement. Now while looking at someone, everyone tries to look at that person in a straight way. That is the shortest path that can follow, right? So the shortest path has a definite direction. Now when someone asks you, look at me, if someone asks you, look at me, there is a sense of direction in your head. From where that sound is coming, where I need to look, you look around to specify the direction. So this is the shortest distance with direction. So this blue color, shortest distance, represents displacement. So displacement is the change in position with the shortest distance. Displacement is shortest distance between 2 points, is the shortest distance between 2 points. That is the shortest distance between Nick's house and Reshmi's house. This blue color line is the displacement, and this also has a specific direction. That is a unique specific direction. So displacement has also direction. But now these black dotted lines and these red arrows represents distance. Now distance has no specific direction. Displacement has specific direction, that he has to look from here to Reshmi's house in this direction only. He cannot look around like this. Now while moving from his house to Reshmi's house, he has to change his direction several ways, in several times. Let's see. While moving from his house to Reshmi's house, he is changing his direction over here. He is moving again. He has to change his direction over here. Again, he has to change his direction over here. Here also. Similar also this case. So distance has no specific direction. And distance is also not unique. Now if someone asks me, what is the distance between Nick house and Rishmi's house? Which are you going to say? If you take this path, you have to cover a longer distance, and if you take this path, you have to cover a shorter distance. So distance is not unique. Remember, displacement is unique, that it has only this, that is the shortest distance between 2 points, but distance is not unique, right? So this is clear to everyone. So distance has a certain specific direction. Distance has a certain specific direction. That's why displacement has a certain specific direction. That's why displacement is said to be a vector quantity, and distance has no specific direction. That is why it is said to be scalar quantity. Now, what is vector and what is scalar? I think I have told you in the previous chapter. If you have any doubt, I am going to make another video of vector algebra, and that is very important, and you really need it for this chapter. Now, to understand vector and vector algebra, I am going to give you another video. But if you subscribe to this channel, I am going to upload it very soon, so that you can get to know this about vector algebra. Okay. So let us understand this displacement and distance. So I think this is clear to everyone. What is displacement and what is distance? You have got a brief description of this. So next I am going to write the difference of distance and displacement. Yes, but before I am writing this one, let me tell you another thing. See, distance is always greater than equal to displacement. Why I am saying this? Distance is always greater. Now, if it has been like this, displacement is the shortest distance, right, between the 2 points. So displacement can be equal to, but be always less than distance. Distance can be greater than displacement, as well as it can be equal to displacement also. Distance can be equal to displacement also. That is a special case. That is a special case. Distance can be equal to displacement also. But remember, displacement is always less than equal to distance, or I can say distance is always less than equal to displacement. Now, distance is always, now another point I am writing, distance is always positive. Always positive. So distance between 2 points is always positive. There can be no negative, no zero. But displacement can be positive as well as zero. But displacement can be positive as well as zero. Now you will ask me, now you are going to ask me, how is the displacement can be zero? How? See, if Nick went to her house and again returned back to his house, what is the net distance? Net distance is this distance and adding this distance. And what is the net displacement? Net displacement is zero, because ultimately he moved back to his original position. So displacement is zero, because final position was that whatever was the final position, end result also the same. Whatever was the initial position, final position is also same. So ultimately displacement is zero. So this is clear to everyone. So I have just explained you the difference between distance and displacement. Now I am going to write the detailed difference between displacement and distance. Now if you have any problem, please feel free to write me in the comment section. So here is the difference between distance and displacement. I have already written it for you, and I hope you are going to write this in your copy so that you can refer to this whenever you want from your copy, or also you can also refer to this video again and again. Now, distance and displacement. Distance is length of actual path traveled by the body from initial position to final position, and displacement is shortest distance between 2 points. So I have just explained you what is the thing. Just if you did not understand anything, Just if you have not understand that part, rewind it and try to understand the story I have just told you between Nick and Rashmi and how they are going to try to meet each other and the way I have explained distance and displacement. See here, you can understand now distance is always positive and never zero. Displacement is either positive or zero. It is scalar quantity that it has no direction. Distance has no direction, and displacement, it is a vector quantity. That means it has magnitude as well as direction. You will get to understand vector quantity a bit more in your later chapters. And it is not unique. Distance is not unique. And displacement, it has a unique path. So ultimately you have understood the difference between distance and displacement. So this is it. Write down in your copy, and if you have any doubt, please write me in the comment section. We are going to understand the difference between speed and velocity. See, what is speed? Just try to understand what is speed. Speed is defined as rate of change of distance. So speed is the rate of change of distance. That means how much distance traveled within how much interval of time. So speed, if I write speed as like just say if I write speed as small s, so speed can be written as like this: distance traveled by time taken. So this is the change of distance traveled by time taken. So here I can say if the motion is change of distance, so this is what speed is: distance traveled by time taken. So speed is rate of change of distance, that means how much distance traveled within how much interval of time. So as it is the rate of change of distance traveled, so we can say speed is always scalar quantity. Speed is scalar quantity. Now we are going to talk about instantaneous speed. Now what is instantaneous speed? So instantaneous speed can be written as like this: s equals to dr dt, or we can say as small dr by dt. So what is dr here? Dr is the change of distance and dt is the small interval of time. Now from here dr by dt, it is very clear to you that is how much change in distance within how much interval of time. Now this change of distance and change of time, this you can see as dr and dt. This actually signifies that is within a very short interval. Now dt represents a very short interval of time, how much distance has been changed. So instantaneous speed means you are trying to find out the speed of any object, any moving object within a very short interval of time, that is at that instant only. So here dt represents a very short interval of time, and dr represents short change in distance. So this is instantaneous speed. So this is instantaneous speed, and what is speed? Rate of change of distance. So what is the difference between speed and velocity? We are going to see it now. So next we are going to understand what is velocity. So velocity is rate of change of displacement. So velocity is rate of change of displacement. So here rate of change of displacement means how much change in displacement occurred within a definite time interval. So velocity is represented as v, and here this arrow signifies that it is a vector quantity. So velocity is vector quantity. Why it is said vector quantity? Because it has direction as well as magnitude. So it is a change in displacement within a time interval. So this is what velocity is. So we can say velocity as instantaneous we can say instantaneous velocity as ds by dt. Now what is ds by dt? See, here I have given an arrow over s. This means this ds by dt means rate of change of displacement, very small change in displacement, very small change in displacement within very short interval of time. Now this you know, dt and ds. Dt means very short interval of time and ds represents very small change in displacement by within very short interval of time. So I hope this is clear to you everyone. So what is velocity? Velocity is rate of change of displacement. That means how much change of displacement occurred. That is whether for a body is in motion within how much interval of time. And this is a vector quantity. And instantaneous velocity, where we will be talking about instantaneous velocity, that is ds by dt. At a very instant, how much change of displacement occurred within how much interval of time. So I think this is clear to everyone, right? Next, we are going to understand what is acceleration. Now, acceleration is very important. Now, acceleration. So, you have been accustomed to acceleration. That is, a car accelerates, a motorbike accelerates. That is, suddenly its speed increases or its velocity increases. So, what is it? See, acceleration is rate of change of velocity. That is, in how much interval of time, how much increase in velocity is occurring. Suppose imagine a bike rider is suddenly increased its acceleration. That means within a short interval, the amount of velocity it has been traveling within few seconds before, that has increased. That means few seconds before, whatever the change of velocity is occurring, now the change is occurring in a rapid speed, that it is increasing rapidly within a very short interval of time. So that means acceleration is rightly defining it that its velocity is changing rapidly within short interval of time. So ultimately we can say that acceleration is rate of change of velocity. So acceleration can be defined as rate of change of velocity. So acceleration is a very instantaneous concept. That means you cannot say as a total acceleration like this. Acceleration is within that instant only. Just imagine a motorbiker is riding a bike, suddenly accelerates. So acceleration is an instantaneous concept. So for instantaneous concept, I can say acceleration as dv dt. That means very small change in velocity within very small interval of time. Now why I have put a as an arrow over here? Because acceleration is also vector quantity. Because acceleration is also vector quantity. This is clear to everyone. Acceleration is equal to dv by dt. So this is clear to everyone. Acceleration is a vector quantity. So acceleration can be written as dv by dt. So we can say acceleration this as instantaneous acceleration. Instantaneous acceleration. See, acceleration itself is a concept of an instant, right? So acceleration can be written as dv by dt. Now we know v is equals to ds by dt. Now if I put the value of v over here, I can say acceleration can be written as d2s by dt square. Now d2s by dt square means here I am double differentiating ds dt. How it has come? Just I am going to explain you like this. See, acceleration was like this, dv by dt. Now if you write dt of ds dt, it come out to be d2s by dt square. So this is how I can write acceleration can be also written as d2s by dt square. Now whatever the unit of acceleration will be meter per second square, and unit of velocity and SI unit of velocity and speed can be written as meter per second. So unit of acceleration, is meter per second square. Meter per second square, this is an SI unit. meter per second square is SI unit, that's acceleration. So this is what acceleration is. Now with this concept of instantaneous velocity, instantaneous acceleration, we are going to solve the 4 fundamental equation of kinematics. Okay, so 4 fundamental unit of kinematics is very important. We are going to study in details. So till now we have understood what is velocity, what is speed, what is distance, acceleration. We have understood all these things. Now imagine what I am trying to say you right now. Suppose a bike rider goes and gets on his bike, switches on the ignition and he starts his bike, and suddenly after starting he goes on. That means what he is doing? He goes to the bike, he switches on the ignition, he is in a state of rest. Now when he increases accelerator, the bike starts to accelerate and he gets to accelerate and he gains more and more speed. The longer the time, the longer the speed he gains, and with his speed in his bike, he can complete or cover a certain distance. Distance, or we can say also displacement. Displacement if it has went to us between, if he has traveled the shortest distance between any 2 points. So this is what can possible. So mechanics deals with these kind of things. Sub-branch of mechanics, as I have told you, statics, kinematics and dynamics deals with all these things. So now we have to understand that there must be some kind of relation between velocity, time and acceleration. There must be some kind of relationship between velocity, time and acceleration. Now as well as with this velocity, time, acceleration, there comes another thing, that is displacement also. Displacement also. How? Suppose a body is moving with certain velocity, then if the body is moving with certain velocity, after some time it is going to cover a certain distance or displacement, whatever you can say right now, because considering displacement be the shortest distance between any 2 points. So this can be possible. So from this what we have studied, this idea is getting into our head, right? Now to put this idea into equation, we are going to understand few things. So come, let us understand what can we say from here. See here, acceleration A can be written as dv by dt. This is all we know, rate of change of velocity. This is the rate of change of velocity. We know this, right? This is acceleration. From here I can say dv, that is change in velocity, is equals to a into dt. Now if we integrate both sides, and we put the limit. Now here is the important part, putting the limit. Suppose the time that you are considering, that is from initially your time was 0, from 0 second up to t second you were considering, up to t second. Time was, you were considering from, time you considered from 0 second to up to t second. When time was at 0 second, I don't know what was the velocity of the object that was moving. So let us consider the velocity be u. At t second, it has gained some velocity, that is due to acceleration. It has increased the velocity, then the velocity becomes v. Now u is here the initial velocity, and v is here final velocity. So you got the idea of the thing. A body is moving with an acceleration from 0 second up to a t second. Its velocity increases from initial velocity to final velocity. Now if we put this limit here, what we get? dv, we get here like a t. Now putting the values, we get v minus u is equals to at. So ultimately we are getting v is equals to u plus at. So this becomes our first equation of motion, v is equals to u plus at. So this becomes our first equation of motion, v is equals to u plus at. So final velocity, this is v is the final velocity, u is the initial velocity, this is acceleration, and this is the time taken t. How much time it took to accelerate. So a body with initial velocity u after t time accelerates and gain a final velocity v. With this equation we can understand the final velocity, initial velocity, and acceleration and time. Giving these values, we can get to know all information regarding these things, right? So this is a very important equation. This equation is very important for understanding the motion or the kinematics of any body, right? Now let us jump to another equation. Let us see what the next equation is trying to say. What we can bring about anything about displacement time with velocity. Let us check out our next equation. We all know v is equals to ds by dt. Here what is ds? Now here ds represents small change in displacement and this is dt means small interval of time. So we can say v dt is equals to ds, right? Now in place of v we have just find out the equation. What is the equation? V is equals to u plus at. So let me put the value of v is equals to u plus at this point. Here v is the velocity of any object, right? So this is the instantaneous velocity. From this represents the instantaneous velocity. This represents instantaneous velocity, right? Now instantaneous velocity is velocity at any instant. So velocity of any instant is v. So velocity of any instant must be started from an initial velocity and that has accelerated to form again another velocity. So this velocity at this instant has to be started from an initial velocity u, which after acceleration has formed this with certain time interval. So we can say v as u plus at. Just now we have found out this equation. This is ds. So now if we integrate, now integrating we can say u plus at dt is equals to ds. Now from where to where we need to integrate, what will be the limit? So when t is equals to 0, that is when time was 0, distance moved, s was also 0. When time was 0, distance moved 0. Just try to understand this for a suppose a motor car or someone is trying to run over a race. Suppose try to understand this as a motor car, which is initially at 0. Now when it starts running, the time goes on, and after a certain interval, that is it moves after a t time, it has moved certain distance, that is s. So we need to integrate this equation. We need to integrate this equation from time equal to 0 to t, and distance we need to integrate from 0 to s, right? So integrating, if you have to put this upper limit and lower limit, so on integrating we get u t plus at square by 2. Now how I am getting this one, integrating, how I am writing this equation directly over here. Now if you don't have any knowledge of integration, that is quite okay. And if you don't have any knowledge of integration, please go and check this link, and here you will get to know the detailed information regarding integration which you really need for physics to do this kind of sums, which you really need for your physics for 11 and 12. That you need. Integration is important. So on integrating this equation, we are getting s equals to, on integration equation we are getting s equals to ut plus half at square. So this is our second equation of kinematics. This is our second equation of kinematics. This is also a very important equation. We can get to know the displacement of any object which is moving with initial velocity u after t time interval if we have the knowledge of acceleration. So next we can say acceleration is equals to dv by dt. Now here I am going to use one trick. So what I am going to use, see here, dv by dt, we can write it like this, dv by ds into ds by dt. I can say like this, no problem, this ds can be cancelled. We can write like this, right? This you know, this kind of thing we have already done in mathematics in our class 9 and 10. All this in these classes we have already done. How to solve this kind of numericals we did, like these things is quite clear to everyone. Now dv by ds. Now what is ds by dt? We know ds by dt can be written as velocity, instantaneous velocity, right? So we can write it over here, and here we can write it like this. This is clear. So now we can say a ds is equals to v dv. Now here we have got this kind of differential equation. Now what to do? We have to integrate now. So let us integrate. Now important part is the limit part. So let us understand what can be the limit. So a body, we are seeing acceleration. Here acceleration remains constant. This acceleration does not change. Here acceleration remains constant. What is changing? The displacement, and here dv is the velocity is changing. So if a body has certain velocity, if it accelerates, then its velocity increases. We all know this. So on increasing acceleration, velocity increases, as well as the distance that it has covered, that also increases. So with increasing the acceleration, that is with increasing the velocity, that is with increasing velocity with constant acceleration, the displacement is also changing, right? So I can say, when suppose initially when displacement was 0, at that time velocity was u, initial velocity. When after velocity increased to v, that is final velocity, is displacement increased to a certain displacement, increased to certain value, that is s. When velocity changes from u to v, displacement changes from 0 to s. This is the limit, okay? If we put this 0 to s and this is u to v, if we integrate this, what we get? Again the formula of integration and little knowledge of integration, I have already made a video. Please go and check that if you don't have any idea about integration. Now if we integrate this, what we get? We get here a s, and here we get v square by 2. Now this becomes as, this becomes v square minus u square by 2. From here I am writing, because I don't have space over here, so here I can write v square equal to u square plus 2as. So this becomes the formula. From here, this step, this 2 is going over here, and then v square can be written as u square plus 2as. So this is what we can say, this is the third equation of motion for kinematics. Here s represents the displacement, acceleration is a is the acceleration, u is the initial velocity, and v is the final velocity. I hope it is clear to everyone. If you have any problem, write me in the comment section, and you can also add me on Instagram. And if you want to share your problem Instagram, you can text me there. I will definitely reply. Okay. Now before I go to our fourth equation of motion, let me tell you something that is important to understand this equation. See, understand this as a car. Now this car is moving. This car is moving with certain velocity, and it also has some acceleration. Okay, no problem in this. Suppose it is moving, I don't know for how much time it is moving or anything like this. What I can say, at nth interval of time, it has already traveled sth displacement. It is moving, right? From first second it has traveled certain distance. For second it has traveled certain distance. For 10th second it has traveled another distance. For 11th second it has traveled another distance. So it is moving. How much distance or displacement it is covering, I don't know. It is covering certain amount of displacement, right? Within this first, second, third, fourth, fifth, sixth, seventh, like. So first second, second, I don't know. So I can say at nth interval of time, let me at nth second, because that is the SI unit. That's why I am saying all these things. Nth second, okay. So at nth second, it has traveled sth distance. Then what will be? That means at n minus 1th second, it has traveled n minus 1th displacement. So after n minus 1th second, it has traveled n minus 1th displacement. After that, if n minus 1th distance means after that, like for example, if I say 9th second, a car is traveling like this. At 9th second, it has traveled suppose 50 meter. at 10th second, that is at 10th second, how much distance it may going to cover. So depending upon the initial velocity at 9th second and also the acceleration of the body or acceleration of your car, you are going to explain me how much displacement it can cover, right? So this kind of formula, this kind of problems can also arise in physics. To understand this kind of problem, we have also formulated another equation. So let us cover that part. See, we can say V is equals to ds by dt. This is the instantaneous velocity. So ds can be written as v dt. This you know, I have just done. So ds can be written as u plus at plus dt. Why I am writing u plus at? Because we know v is equals to at, and here a is the constant acceleration. Here a is the constant acceleration, right? Here a is the constant acceleration. So from here, if we integrate now, if we integrate this, what can we get after integration? Now here is the main trick. Here I will place the lower limit and upper limit in the same way I have just explained you just now, that is n minus 1th second to nth second. It has covered distance of s n minus 1th to s nth second, right? So for n minus 1th second to n plus to nth second, I am going to round the limit, that is n minus 1th to nth second for this time interval dt. How much distance it is traveling? So for this one, for this time interval, it has must have been traveled s n minus 1th distance to s nth distance. So on integrating, we can get like this, s n minus 1, this is s n, and we are going to get something like this, right? We are going to get something like this. Now if we integrate, after integrating, we have placed the limits. Now I don't have any space over here. I can write, okay, let me just try over here, right, in this part. So this come out to be Sn minus 1, and here we are going to get u n minus n plus 1, and here we get half a n square minus n minus 1, that square. So we get something like this. Now let me evaluate. So I have to rub this part. Evaluating, we get Sn minus 1 is equals to u, this n cancels, plus half a, this part is different, and so this come out to be n square minus n square minus 1 plus 2a plus 2n plus 2n. So here n square cancels, so we get Sn minus 1. So this come out to be u plus half a, and this gonna be 2n minus 1. So this is the equation I am getting. So this is my equation. So Sn minus 1, we can say Snth distance. So Snth distance, it has traveled as u plus, so this becomes our fourth equation of motion. So I hope this is clear to everyone. So if you have any problem, check this out, rewind this video again and again, go through these numericals, so go through this derivation again and again, try to find out what is happening. If you can't figure out anything, write me in the comment section. I'm again saying you, or you can also add me on Instagram. If you have any problem, I'm always there to help you. Okay? So thank you for today. Please don't forget to subscribe this channel. If you subscribe, like and share this channel to your friends, then I'll get more inspiration from you to upload more this kind of videos so that understand physics a lot better way. Thank you so much. Thank you for your love and support. Thank you.